Division of complex numbers. Welcome today to algebra class of King Solomon and David Piquosi. And today we'll be looking at division of complex numbers. Division of complex numbers. Okay. Now, you already understand that a complex number is in this form x plus iy. And we have the real part of the complex number, and we have the imaginary part of the complex number. Now, if I have two of these complex numbers and I want to divide them, how do I go about it? Okay. So now, what we do here is that let's take two complex numbers, z1 as x1 plus y1i, and z2 as x1 plus x2 plus y2i. And we are asked to find z1 on z2. Okay. Now with this, what we do is that z1 on z2 is simple as x1 plus y1i divided by x2 plus y2i. Now we can simplify this, and we need to simplify this to get the real part, and we also need to simplify to get the imaginary part. But before that, we have to understand that I squared is always equal to minus 1 because I is equal to root of minus 1. Okay, you have to understand this very well. Okay, now to do this, we have to multiply the numerator and the denominator by the complex conjugate of the denominator. So to do this division, you have to multiply the numerator and the denominator both by the complex conjugate of the denominator. And z2 is the denominator, so its complex conjugate of z2 becomes x2 minus I y2. Okay, so you multiply here by x2 minus I y2, and multiply down here by x2 minus I y2. Okay, now when you do this, then we can now start multiplying them. So we get here x1y x2 plus y1 y2, and the other side of it becomes plus x2 y1 x1 y2 I. Okay, so when you simplify this part here, that is the top part, xi plus y1i and x2 minus I y2, you're getting x1 x2, sorry, you're getting x1 x2, you're getting minus x1 I y2, and here that'll give you plus y1 I x2, and this one will give you plus y1 y2 I squared. Okay, so in this one you'll be getting. And now here, this one, because of the I being become imaginary part, this one will become minus 1. So get here y1 y2 into bracket. So here is minus. So here is minus already. So you get minus 1, which becomes positive, plus y1, y2. Okay, so that's what you are getting here. And this second part is what we are also getting here. Okay, so this is what we get. Now from there, you divide by, when you add this and this, you simply get x2 squared plus y2 squared. Okay. So we can check on this one too. The denominator is x2 plus y2i multiply x2 minus I y2. Okay, so check on these two also too. You'll be getting x2 squared plus y2 squared. Okay, so what do you get here? Here you get x2 squared plus x2 I y2. This one will give you minus x2 I y2, and this one will give you minus y2 squared I squared. So this will take this away. So you get x2 squared. And this one give you, because we will give you minus 1. So minus y2 squared minus 1 will give you plus y2 squared. And that's what we are having here. Okay. So now when you get this, you can now separate this into the real part and this into the imaginary part. So the real part, you get x1, x2 plus y1, y2 all divided by x2 squared plus y2 squared. And this is the imaginary part plus I, and this is the real part. The imaginary part, because of the I, it becomes x2y1 minus x1y2 all divided by the denominator plus y2. And this is the breakdown for the division. So if I want to divide two complex numbers, this is the breakdown for you to do that particular division. Now let's take one question. And the question says, express. So this is the question. It says express the complex number z in the form x plus iy, when you have z to equal to 3 minus 2i all divided by negative 1 plus 4i. Okay, so this is the question you have been given, and you are asked to express z in this form. That is to say, you are supposed to operate on this using the division principle in complex number, and this is it. I said always, if you can memorize this, there's no need memorizing this in your head. You know that x1, y2 is the denominator, so that's squared. This one is x1, x2 plus y1, y2. And this also, you take the x2 first, y1, x1, y2. And if you have this in your head, you can always write it. When we did the multiplication, that one was also simple. We have x1, x2 minus y1, y2. And the I part becomes x2, y1 plus x1, y2, I. So this was simply for the multiplicative aspect, and this is for the division aspect. There's a way you can memorize it, and that's the simple. You should just look at it and memorize it off here. Okay, so now we have to bring this formula, and that will help us to easily solve this. So therefore, let's take this one as the first one. So 3 minus 2i, here you have x1 to be 3, you have y1 to be minus 2. And the second one is minus 1 plus 4i. You have x2 to be minus 1. You have y2 to be 4. So now if you write the formula, up here, which is x2 plus y1, y2, all divided by x2 squared plus y2 squared. So I'm trying to write the formula up here, which means you can also do the same. x2, y1 minus x1, y2, all divided by x2 squared plus y2 squared. And this is the imaginary part. Am I right? Okay, so that's the same thing. So now x1, x2, which is 3 times negative 1. So that will be 3 times negative 1 plus y1, y2, which is negative 2 times 4. And that gives you x2, y2. So x2 squared, which is minus 1 squared, plus 4 squared. Okay. Plus I, the imaginary part. This is the real part. So if you do the real part, you are getting, this will give you minus 3, this will give you minus 8. So minus 3 minus 8 all divided by, this one will give you 17. So therefore, we are getting minus 11 on 17 plus, so we have to do the imaginary part, which is x2, it's minus 1, y1 is what? Minus 2, minus x1, which is 3, y2, which is 4, all divided by the same thing. It's the same thing here. So it's still what? 17. Okay, so therefore we are getting plus I, this minus, this will give you 2 minus 3, 4, that is 12, all divided by 17. So you are getting, here as what? I into brackets minus 10 on 17. So therefore the final answer, when you find this, will give you minus 11 on 17 minus 10 on 17 I. Minus 10 on 17 I. Okay, so the real part is minus 11 on 17 and the imaginary part is minus 10 on 17 I. Okay, now there are some properties you should know under the division. There are also some properties you should know under the division. And now with the division, let me do the division here, and let me link it aside with the multiplication we've done earlier so that you get it. So with the properties, and the division, anytime you have the modulus of Z1, Z2, it is equal to their individual moduluses, you should take note. So this is the first property. That was the same way for multiplication. If you have Z1, Z2 multiplying, it's the same as their individual moduluses, and I proved that in the previous videos on multiplication. And B, it says that anytime you have the argument for multiplication, you said if you have the argument of their multiplication, the two complex multiply is equal to their individual, the addition of their individual arguments. The addition of their individual arguments. That is the same way you have the argument of Z1 divided by Z2 is equal to the argument of Z1 minus the argument of what? Z2. But for multiplication, it's equal to the addition. But for division, the argument is what? The subtraction or the difference between the individual arguments. Okay. Thank you very much for joining this class, and I'm hoping you get a lot of questions to solve on this. Thank you.